Uh, Good morning to one and all. Today we will discuss a topic that is a regression. So previous classes we have discussed about correlation. So as we studied that correlation, the correlation studies the relationship between the variables. So what is the need of regression? For example, if there is a correlation is topic is there. So what is the need of regression? So here the regression we need to understand the in-depth analysis. So in the correlation analysis, we have studied only the relationship between the variables, but we didn't study that which variable can cause to the another variable, right? So in regression analysis, we can study that. So which variable is a cause to the another variable? There is a cause and effect relationship in the regression analysis, whereas in correlation, there is a degree of association or simple relationship between the variables. So that is a main reason to study the regression. So simple, you can remember in correlation analysis, we can study the relationship between the variables only, but we didn't study that which variable is causing to the another variable. Nothing about which variable is affecting on the another variable. Which variable is causing to the another variable. Whereas in regression analysis, we can study that which variable is causing to the another variable. Nothing, how much it can cause. So we can study in the regression analysis. Step by step we will discuss what is meant by regression and what are the types of regressions are there, then we will discuss. So first we need to understand that is introduction part. The first we need to understand that who is the father of regression analysis. See, the father of regression analysis, that is Carl F. Gauss. Carl F. Gauss is a father of regression analysis. Then the term of regression was first used in 1877 by Francis Galton. Simple, you can remember that the regression term as used in the statistics in 1877 by the Francis Galton. Francis Galton. Then why in which subject area or which disciplines the regression has been contributed? See, for example, its contribution, the regression contributes to the physics, mathematics, astronomy, as well as other social science disciplines. So not only these three, so there are a large number of subjects or disciplines they have used the regression analysis. Nothing but, so in the general, if you take into any science subject as well as social science subjects, so there is a cause and effect relationship. Cause and effect relationship. Cause and effect relationship. For example, if you take into account, as I told you that earlier classes, for example, if you increase your time, nothing but study hours. If you increase your study hours, so the study hours may affect on your marks. Nothing but when you are increasing your study marks, or nothing but when you are increasing the study hours, so the marks you are going to get more. When you are decreasing your study hours, you may going to get less marks. Nothing but, so this is the one variable which can cause it to the marks. Nothing but when you are increasing your number of study hours, so it can impact on marks. So that is the thing that we can study in the regression analysis. So in order to study that cause and effect relationship between the variables, we can use regression analysis. So in physics also we can use this kind of relationship, and whereas in mathematics we can use, and astronomy. Some people, though, for example, if you believe some gods, for example, somebody will give the advice too. So you can visit temples in 10 times, you will problem may be resolved. So that is a some there is some cause and effect. For example, if you believe the god, okay, if you went to 10 times to this particular temple, if the problem is solved, you can believe that if I went 10 times to a temple, that's why my problem is solved. For example, if your problem is solved off only, for example, if you increase the number of visits, your problem may be decreased. It case that there is cause and effect relationship. For example, if you take in astrology or astronomy also, they can use this regression analysis also. So we need to understand what is regression analysis. So this is a basic introduction of, there's nothing but who was father of regression analysis, and who was used the regression analysis in the first time. Then its contribution to the physics, mathematics, statistics, and astronomy, and other disciplines, other social science disciplines also we can use. Not only these three, we can use regression analysis for the more sub disciplines. So we need to understand that what is mean by regression. What is mean by regression? The regression is the study of the relationship between the variables. Sometimes they will ask that regression is the study of the average relationship also, average relationship between the variables. So here variables is nothing but there is a dependent variable and independent variable. We can identify that which is a dependent, which is independent. For example, if you take into account that, so your number of hours is a independent variable, nothing but, so if you increase the number of hours, nothing but study hours, your marks may be increased. So if you changes in the number of hours, nothing but study hours, it may affect on the marks, nothing but marks is a dependent variable, nothing but marks depends on the how many hours you have studied. Clear? So that is thing. The regression is the study of average relationship between the variables. Variables in the sense dependent and independent variables. Whereas in regression analysis, we cannot define that which is dependent and which is independent. But in regression analysis, we need to define that which variable is a dependent and which variable is a independent variable. And then understanding the causal relationship. As I told you that there is a causality relationship between the dependent and independent variable. That is the case. Understanding the causal relationship between the dependent and independent variables. And the regression is also to predict the relationship in the future. For example, we can estimate the future values also on the basis of regression results. See, the regression can also useful to predict the future values. Think, but so as I told you that, so if you increase your study hours, you will get you are going to get 90 marks. For example, if you study 9 hours per day, for example, I may conclude that you are going to get 90 marks in particular subject. For example, if you spend 8 hours per study hours, for example, you may going to get 80 marks. If you spend only 3 hours, for example, you may going to get 40 marks. That is my prediction. Okay. So on the base of the values, we will predict the future certains or future relationship in the between the two variables. Then, so regression is one of the most commonly used tool. For example, here, if you take into account in research field, the projects are MA project, MPhil projects, PhD projects, or PDF projects, or other major and minor research projects, or any studies or publication of articles and manuscripts, some other books. So they can use the regression analysis where it is important. For example, so it is a most common tool for business analysis. For example, if you take it over any business, for example, if you take into account. So as I told you that if you are increasing the number of advertisements in a particular company, your sales may be going to increase. For example, see, if you take into this is the advertisements. Okay. So if you spend more cost on advertisement, nothing but if you spend a lot of amount on advertisement, your sales may be going to increase. Right? So in business, for example, if you are advised to the particular company, so if you take it, if you put advice to the manager or if you are the chairmen or directors, so if you spend this much amount of on advertisements, your sales may be going to increase. For example, see, so we will prefer to purchase the commodities where we will get more advertisements. For example, if a particular company will give advertisements in particular, if you take cars, for example, so we will see newspapers, some online. We will see that how much offer is they are giving. Nothing but how which company is giving more advertisements towards to the offers or the related things. So we will attract and we will look into that particular commodity only. We will ready to purchase the particular commodities. For example, if nobody is not giving any advertisements, we cannot prefer it. But whereas in application when you take into account in the business, which commodity is more popular, they may not give more advertisements also. That is the case. For example, which is already famous, so they don't want to spend more amount on advertisements. For example, if you take it like a new company or new, if you take Kia cars, so they are giving more advertisement in order to attract the customers. So in that case only, we will use that particular regression analysis. How much they are spending on advertisements and how much sales is going to increase. Then it is easy to use and applies to many situations. For example, the regression tool is very easy to apply and as well as to the many situations. For example, where it is a causal effect relationship, we can use regression analysis. So am I clear about this introduction, dear students? Hello?
Yes, sir.
Yeah, thank you. That. And so in mathematics and in statistics, we can write regression equation like this: y is equal a plus bx, a plus bx. Or sometimes we have written in the regression in the whereas when you study 9th and 10th standard, so yx plus mc. Sorry, I think y is equal mx plus c, mx plus c, y is equal to mx plus c like this. See, y is equal to a plus bx, or else we can write y is equal to beta 0 plus beta 1 x1 also we can write it. This is a simple regression equation, that is y is equal a plus bx. So where y is equal dependent variable, y is equal dependent variable, or else we can call influenced variable and explained variable, or regressend also. You can say regressend. And whereas a is called intercept, a is called intercept or constant, whereas a is called constant or intercept. So what is b here? We can call slope or coefficient or parameter. Slope, coefficient, parameter of x variable, of x variable. So what is x variable here? That is a independent variable, that is a independent variable. The independent variables also called influencing variable and explanatory variables and regressors also we can call regressors. Simple here, this is influenced variable, this is influencing variable. Explained variable, this is explanatory variables, whereas dependent variable is regression, here regressors. Okay, so we see what is constant a. As I told you that a is nothing but intercepted constant. So what is a? Nothing but a is equal to value of y when x is equal to 0. X is equal to 0. For example, if you take into account y is equal a plus bx. For example, if you take a is equal something, if you take 2, you can assume a is equal to 2, b is equal to 0.5, 0.5. If x is equal to 0, 0.5 into 0, 0. Then a is equal 2 only. That is y is equal also 2, because a is equal to value of y when x is equal to 0, right? Then b is equal to, what is mean by b? That is change in y due to unit change in x. Nothing but slope. Nothing but where we have studied the slope, that is called delta y by delta c, or delta nothing but change in change in income by change in consumption. For example, when you are calculating that MPC, marginal propensity to consume, that is a delta y by delta c. That is a change in income by change in consumption. Right? That is, you can say slope. Right? That is called here change in y, nothing but here dependent variable due to change in x units. That is b is equal change in y due to change in x. We can come to know that how we can calculate a and how we can calculate b. Okay, don't worry. Is it clear now? Hello, dear students. Okay, okay. Yeah. Next, we need to understand that what are the regressions are there. Nothing but what are the types of regressions. What are the types of regression? So there are 7 types of regressions are there. So along with this, there are other types of regressions are there. When you comes, for example, when you enter into the economic subject, you will get more number of regressions. Okay, but basically we need to understand this 7 is enough in the basic for the BA, for the graduate level. It is enough. These types of regressions. So when you enter into the master course as well as MPhil and PhD, you may get different types of regressions also. Okay. So on the base of the other regressions, they are based on the this type of regressions only, but there are different types of regressions also there. So here we need to understand these basic types of regressions. The first one is a linear regression. Second one is a non-linear regression. Third one is a simple or bivariate regression. Then fourth one, multiple or multivariate regressions. Then fifth one, partial regression, partial regression. Sixth one, log linear regression, log linear regression. So whereas in log linear regression, we have the two types of regression. There is a log lin modeler or log lin regression, or second one lin log regression. Lin log regression. Then seventh one double log or log log regression. Log log regression. So please keep in mind that we have basic types of regressions in our basic graduate level. So the linear regression, non-linear, simple regression, multiple regression, partial regression, log linear regression, double log regression. Okay. Then we will discuss what is meant by linear regression and non-linear, simple and multiple, partial, log linear and double log. Then first we need to discuss that what is meant by linear regression. Linear regression. So here simple the linear regression. So linear regression is a linear approach to the modeling the relationship between the scalar response, nothing but dependent variable and one or more explanatory variables. Or simple if you take into a linear regression. So when you write in the equation, so if the power value is equal to 1, that is linear regression. Simple you can remember. When you write like this equation, y is equal to a plus bx, whereas power is equal to 1. Here x power is equal to 1. When you are not writing anything, you can assume that the power is 1. If you write 2, the power value is 2. Okay. So when you write like this, y is equal to a plus bx, it seems there is a linear regression. Linear regression because the power value is equal to 1. Okay. So simple, that's a linear regression is a linear approach to the modeling linear relationship between the scalar response. That is called dependent variable and one or more explanatory variables. So the case of explanatory variable is called simple linear regression. The case of explanatory variable is x. So here the x independent variable's power is equal to 1, or if the power value in the particular equation, if the power value is equal to 1, that equation is called linear equation or linear regression. Simple in our statistics. So the linear regression is also called OLS. 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 What is OLS? That is ordinary least square method. Ordinary least square method. So we will study in the next class what is meant by OLS and how we can study the OLS. So there are some properties are there we can study tomorrow. So the linear regression formula is y is equal to a plus bx. A plus bx. Then what is non-linear? Second one is a non-linear regression. What it is non-linear regression? So it implies a curved relationship, which is a non-linear combination of the model. Non-linear combination of the model. What is a non-linear? Nothing but it is quite opposite to the linear model parameters and depends on one or more independent variables. Okay. So the non-linear regression is also called curvilinear regression. Curvilinear. When you take into account that the data of nonlinear data, so if you plot the graph generally, you may get curve, but it is not a straight line. But whereas in linear equation, if you take into account the data, if the data seems to be linear, okay. So if you plot the graph, you may get straight line. But whereas in nonlinear, so you may not get straight line curve, but you may get curve, but which is curvilinear. It may be U shape, or it may be M shape, or it may be circle like this. There is a curvilinear. So the nonlinear equation is simple. You can remember nonlinear regression is nothing but if the independence variables power value is more than 1, it is called nonlinear regression. See, whereas if you take the nonlinear equation, y is equal to beta 0 plus beta 2 x1 square beta 3 x cube x3 cube. It means the power value is 2, its power value is 3. It means that this is a nonlinear equation because the power value is more than 1. Okay. So if the power value is 2, we can call that is a quadratic regression also. Sometimes, for example, if you take into account y is equal to b0 b2 x2 2 or up to this one, up to x2 square, it may be called quadratic regression. For example, if you take into account this y is equal to beta 0 beta 2 x cube 3, So it may be called polynomial. Okay, for cubic equation, cubic regression also sometimes we use. Okay, so simple, don't bother about non-linear regression is nothing but simple. So if the power value is more than, so if the independent variables power value is more than one, it is called non-linear regression. Simple. Okay, is it clear now? Hello, dear students. Let me. Who is
Yes, sir.
just please unmute. Okay, I'm getting some disturbance. Okay, is it clear now? Then
Yes, sir.
okay, thank you. Then next one, third one, simple or bivariate regression. So what is bivariate? As we have studied in correlation, bivariate correlation nothing but two variables only. So your simple regression is nothing but there is a if there is a causal relationship between the two variables, only one dependent variable, one independent variable is called simple regression. Okay, so if there is a causal relationship between one dependent variable, one independent variable is called simple regression or bivariate regression. Bivariate is nothing but two. That is in the within the two variables, there is one is a dependent variable, another one is a independent variable. So as I told you that equation, the y is equal beta 0 plus beta 2 x2. Only this is a one dependent variable, y is a one dependent variable, x2 is a one independent variable. So there is only two variables, y is a dependent, x2 is a independent. So this b is a constant intercept, beta is nothing but slope of the x2. Then multiple nothing but more than one. See the multiple regression or multivariate regression. So if there is a causal relationship between the one dependent variable and two or more than independent variables, two or more than two independent variables. Simple multiple regression in the sense, if there is a causal relationship between one dependent variable more than one independent variables, more than one ఒకటి కంటే ఎక్కువ independent variables ఉంటే దాన్ని multiple regression అంటాము. For example, if you take this equation, y is equal beta 0 plus beta 1 x1 beta 2 x2 plus dot plus bn xn plus error. For example, if you take this is a beta 0 beta 1 beta 2, there are two independent variables. So up to n number of independent variables. That is called multiple regression. So as I told you, the y is called dependent variable. So beta 0, beta 1, beta 2 is called coefficients of or parameters or slopes. So x1, x2, as I told you that x1, x2 is nothing but here explanatory variables are independent variables. Okay. So in the model, uh, how many independent variables are there? Here, two. So up to n number of independent variables we can say. So that is the case. There is a multiple regression. Is it clear now, dear students? Have you observed the difference between the simple and multiple regression? Hello? Hello? Okay. Then next one, partial regression. Partial regression. See, in the partial regression, what we have to understand here, see, when you are understanding that multiple regression only, we can easily understand the partial regression. What is partial regression? See, if there is a causal relationship between one dependent variable and one independent variables, when other variables are constant, For example, if you take into account this equation, y is equal to beta 0, beta 2, x2, beta 3, x3, beta 4, x4, for example. So there are how many independent variables are there? 1, 2, 3 variables, independent variables, one dependent variable. For example, if you want to know that, for example, if you take demand analysis, demand, why is nothing but demand is depends on price, income, and other price of substitute goods, complementary goods, for example. So when you want to examine the relationship between only demand and price, what you have to write? So there is an inverse relationship between demand and price when other things are remaining constant or when other things are remaining or ceteris paribus. ఇతర కారకాల్లో మార్పు లేకుండా స్థిరంగా ఉన్నప్పుడు మాత్రమే we can assume like that. So for telling me students, see, so here when there is a relationship between demand and price when other variables are kept constant or are constant. Then we need to understand that if only if the price changes from 1 to 2 rupees, how much demand changes when income and other variables are constant. That is called partial. For nothing but partial is nothing but partiality. Nothing but we will keep others are constant. If we are increasing some variable, how much can affect on another variable? Nothing but individual influence. We can say that individual influence. For example, if you take in a group, there are 5 members. For example, if one member is absent, how much the group work? Nothing but how much output of group of 4 members. If they include another person, how much the output of group? That 5 members. Nothing but when other things are remaining constant, nothing but we are holding, nothing but we are kept constant of other variables. How much can change in the dependent variable? In that case only we can use partial regression. Then log linear regression. What is mean by log linear regression? So here, then log linear regression. See, if there is a causal relation between the one dependent variable and more than one independent variables with lagged values, with log values. So, for example, if I take into account log linear regression, say when you take into account, we need to convert our data into log forms. For example, if you want to know that the growth rate of GDP from 1990 to 2020. So you will need to take that within this 30 years, how much the growth of GDP. Then you need to take the data of GDP and time. Okay. So whatever the GDP is there, you can need to convert into the log forms. Log forms. Then here, y is nothing but the dependent variable is GDP. And here, instead of writing x2, we can write in time series, we can take t. So time is a independent. As time increases, how much the GDP is going to increase? Okay. So here, as years is going on, how much the GDP is going on? Nothing but so as years is increases, how much it can influence the GDP? Nothing but as time increases, whether our GDP is increase or decrease, we need to study. Time is a independent variable, GDP is a dependent variable. So in that case, we can need to convert the data into log form, log form. So log of y nothing but log GDP, that is beta 0 plus beta 2 x2, nothing but x1, or we can take t also. Instead of x2, we can take t in time series. So this is called log lin model. This is called first equation or first model is called log lin. Simple, you can remember log lin. Okay. For example, if you take into account some in other cases, you need to take or you can convert the data into log form as in a independent variable. For example, whatever you are going to take as an independent variable, that data you need to convert to the log forms. Only what within the equation, if the particular variable or dependent or independent variable is converted to the log form, we can say log lin model or lin log model. So for example, in the second case, y is equal to beta 0 plus beta 2 log x2. Log x nothing but here I have changed that. Nothing but I need to change. I think but I need to convert the data. Nothing but I need to convert the data into log form of independent variables. So in that case only I need to write y is equal to beta 0 plus beta 2 log x2. This is called lin log model. Lin log model. Lin log model. This is a log lin model. Please remember this question will ask in the set net and other exams also, PG entrance also. So what is the difference between lin log model and log lin model? Lin log model, log lin model. First demo lin log model. Then sorry, log lin model first log lin, then lin log model. Second one is the lin log model. Then next one, double log regression. So for example, earlier I told you that in the previous slide, as I told you that only one side we have taken, that is the dependent or independent side. But if you want to take the data, nothing, if you want to take the logs as a both sides, there's a dependent variable and independent variable. That is the case. There's a double log model or log regression. if there is a causal relationship between one dependent variable and more than one independent variables with lags, with lags in the both side, dependent variable and independent. See, log y is equal beta 0 plus beta 2 log x2, or sometimes double log or double natural logarithm regression also. Natural logarithm nothing but ln. So ln, this is ln, not I, it is ln, nothing but natural logarithm. So we can convert the data into the log form, or and natural logarithm also we can convert. That is the ln symbol. Ln log is nothing but log. Natural logarithm ln we can denote in ln. That is ln is nothing but natural logarithm. Ln y is equal beta 0 plus b2 ln x2. Instead of log, we can put ln. Okay. So here these are the types of regression analysis in basic graduate level. It is enough. So when you enter into the master course, you will get different types of other regression models also there. And by studying that regression also, what we can get it? Think about what are the use of regression also. Then deeply we can discuss in the after completion of this chapter also we will discuss that what are the use of regression also. And here when you convert into the data into log form, this is log LG, LOG and LN. What is the use of when we convert the data into log form? Simple, when you convert to the log form, the results, whatever you are going to get beta 0 value, beta 2 value, here beta 2 and here beta 2, that gives the elasticity value, See, for example, it gives the elasticity of Y if you take a quantity demand with respect to X. For example, X is nothing but price. This is demand. Nothing but if how much percentage change in price can affect on the changes in percentage change in demand. So, for example, if the price is increased by 50%, a particular commodity, how much demand is going to decrease? How much percentage is going to decrease in the demand? That is called elasticity. Nothing but so the responsiveness in Y due to the changes in X variable, or responsiveness in dependent variable due to changes in independent variable. That is the elasticity, or the degree of responsiveness. Sometimes we can call the degree of responsiveness. And the natural logarithm applied to an exponential equation transform the equation to linear equation in logarithm. For example, if you take into account when your data is nothing but when the natural logarithm applied to exponential equations. For example, when you have the equation is exponential, nothing but power is more than 1, 2, nothing but equal to 2 or 3, 4, 5, 6. When you are that kind of equations, so you need to transform your data, or you can change your data into, or you can convert your data into log form or natural logarithm form. Is it clear that am I clear that what is meant by regression and what are the types of regression analysis? Hello dear students. Hello. Hello. Are you there? Arnurod, Niharika, Nandini and other people.
Yes, sir. Clear, sir.
Okay, fine. Then there is a one topic.
Yes, sir.
Within 1 minute, we will close the session. See, there is a regression line. Regression line. But after completion of how we can estimate the regression also, after getting, we will get the regression line. But we need to understand the basic concept of regression line. So here, a regression line is a graphic technique. Simple regression line is a graphic technique to show the functional relationship. Nothing but in order to know that what is the functional relationship between the dependent and independent variable, we can draw a line that is called regression line. On the base of the x values and y values, we can get a line. That line is called regression line. The regression line is nothing but simple. It is a graphic technique. Nothing but on the base of graph only, we will do the graphic presentation. Nothing but graphic technique to show the functional relationship between the two variables, that is a y and x. So there is another person who is famous person, Galton. According to that Galton, the regression line shows the average relationship between the two variables, that is the dependent and independent variables. As I told you that earlier, so the regression is nothing but the average relationship between the two variables, that is the independent and independent variables. So here Galton told that the regression line shows that Average relationship. Average relationship between the two variables. So how we can find out the regression line? Simple C. So this is a regression line. For example, if you take into account, so this is a negative slope, downward slope. See, this is a regression line. This is a y variable, and this is a I have taken x variable. So that is called the regression line. So basically, we will get how we can draw a regression line by using that values. Also, I will show you in the next class. So, for example, if you take into account, this is a regression line. I will show upward and positive and negative also. I will show. Okay. Then okay. Hello, dear students. Am I clear now? Hello.
Yes, sir.
Okay. Thank you very much. If you like this video, you can share and subscribe. Thank you.